Okay. All right. So let's see if we can graph it. So I want to find out all the fun stuff about it. I don't know. Want to do what we did last time? Just start with the intercepts. Sure. So how do I find the intercepts? Is someone talking?
Yeah.
I don't think they're talking to me though. I think it's just their mic isn't muted. There we go. Okay.
Yeah, that's a good point.
I know.
What if the recording thing just messed it up?
They could unmute themselves.
I wouldn't unmute. If the teacher muted me while I'm trying to explain something and they muted me, I wouldn't unmute.
It didn't sound like they were talking. It sounded
No, it sounded like they were talking to someone.
it could have been like someone.
So
It could have
when
been
you
in the
push
background.
to the red and you just get muted by the teacher, just like, oh, all right.
I'll tell you what. That was my when we first had to do these Zooms. The favorite thing was that class. Yeah, you want to talk? I don't think so.
Kick them from the meeting.
Yep.
Just start telling us about pranks today.
All right. So, all right, let's find the intercepts. Let's find the, which ones do we want to find first? Let's do x-intercepts first. So the x-intercept, I need to solve this equation. When does the function equal 0? So when is the height 0? That's where it hits the y-axis. So that's when this equation equals 0. To make a fraction equal 0, you just need to make the numerator 0, right? But we can't make the denominator 0, so it can't be 2 or negative 2. So I need 2x squared minus 18 to be 0. So I need 2x squared to equal 18. So I need x squared to equal 9. So x has to be plus or minus 3. So we have 2 intercepts already. Very good. Let's find the y-intercept. Y-intercept is easier because you just have to plug in 0 rather than solve. So if I plug in 0, I'm sure you guys can do this one in your head, but we can write it all out. It's good. So I plug in 0. 0 squared is 0 times 2 is 0. 0 minus 18 is negative 18 over 0 minus, that's going to be negative 4, which is the same thing as 9 over 2. Because we're graphing, let's just call it 4.5 so that we can find it on the graph easy. Okay, so we have our y-intercept. We have our x-intercepts. That's a good start, right? And back in our Algebra 2 days, we learned how to do that. And here it comes back. All right, so what's the next thing? Let's find asymptotes. Vertical and horizontal. Do we have any vertical? Let's do vertical asymptotes first. Do I want to go down or right? Let's go down. How do I find out where there's a vertical asymptote? Perfect. So it's when x squared minus 4 equals 0. So that's when x squared equals 4. So that's when x equals. Ooh, we have 2 vertical asymptotes. In Algebra 1 today, I showed the kids their first asymptote.
Proud moment.
I don't think they cared. The horizontal asymptote.
That's like the degrees.
Yeah, that's when you do the degree comparison. So the degree on the top and bottom are the same, right? So it's going to be the ratio of the leading coefficient. So it's going to be 2 over 1, which is 2. Oh my gosh, we got so much information. I want to start graphing now.
Calm it down.
Okay.
Pop the asymptotes off. See what happens.
We'll get there. We'll get there. All right. What else do we need? Intervals of increasing, decreasing, max mins, intervals of concavity, point inflection. This is where all that derivative calculus stuff comes. So here we go. A nice quotient rule followed by a quotient rule, the chain rule for the second derivative. Here we go. Ready? Good. All right, let's do it in a different color. What's a good derivative color? Interesting. So I'm gonna let you guys go. You guys start off by taking the derivative, and then I'm gonna put my derivative up, and you guys can check your work. Good practice.
If you started with green so that the derivative was blue and yellow.
Because they mix and make purple. Wait.
Like if you started with green and then the first derivative is blue and the second derivative is yellow, like the derivative is
Oh. Okay. Yeah, I can go with that. I think sometimes too, like if I highlight in yellow and I highlight in like green, no, maybe not. I think they
yeah, no, they do mix. You can't see it very well on the board, but you can see it on here.
There it is. Anyways, find that derivative.
Should we do both derivatives?
Well, if you really want to.
Just save that.
All right, I'm gonna start doing it, and you guys, if you guys keep working, and then you guys can check it with mine and see if we get the same thing. Careful with that negative. All right, so I got the first derivative was 20x over x squared minus 4 squared. How did we do?
I did not get that. I think it's a negative 36.
No, so this is nothing that happened last time.
Oh.
Think of this as like a negative 2x. So that, or you just distribute the negative in first. That's gonna be a negative and a positive. So it's good, yeah. That's that negative. I think someone asked that last class and talked about it for a little bit. Yeah. All right, so there's our derivative. Anyone get that? Two out of 8, nice, okay. So we have our first derivative. Now I want to find out the increasing or decreasing, I need to find out where the derivative is either 0 or undefined and make our sign chart. So I want to find out where the derivative is 0 or where the derivative is undefined. So the derivative equals 0 when the numerator equals 0 because it's a fraction. So 20x equals 0 when x equals 0. And it doesn't exist when the denominator equals 0, which we already know that's plus or minus 2. Those are not critical points, even though the derivative doesn't exist there. Why are they not critical points? We haven't done any signs. And you don't need to have sign change to be a critical point. To be a critical point, the derivative needs to either be 0 or does not exist, but the function has to exist at those points. And what we already know what happens at 2 and negative 2.
Oh.
Those are our acidotes, right?
Oh.
So it makes sense that the dirt doesn't exist there. Okay, so -2 and 2 are places where we could have a sign change. However, they're definitely not critical points. 0 could be a critical point. I'm not even gonna write not critical. I'm just gonna write asymptote. Cool so far? All right, so how do I find out where it's increasing and decreasing? What do I do with those? Plug it, all right, so plug what in?
Plug, big 2, 2.
Well, if I plug -2 in, I'm gonna get DNA. If I plug 0 in, I'm gonna get 0. And if I plug in 2, I'm gonna get DNA. I already know what I'm gonna get if I plug 2.
Numbers like,
In between.
Right.
one,
Yeah.
one, other thing.
So we'll look at like -3 to find out what's happening here. We'll use -1 to find out what's happening in here. We'll use 1 and 3. All right, so we're plugging into the derivative now. So looking at the derivative, the first thing that I'm seeing is the denominator, no matter what number I plug in, is going to be positive. How do I know that?
Squared.
Because it's something squared. Okay, so the denominator is going to be something positive, no matter what.
Well, from then on,
So that from then on, let's just look at the numerator.
pretty easy, it's just one number.
And the numerator is just 20x, right? So if we input a negative, we get a negative. If we input a positive, we get a positive. Not too bad. So do we have a max or a min?
Yeah.
Where?
You have a min at 0.
Right, it was not at an asymptote, which makes sense. Well, it could have had a sign change at an asymptote. I take that back. So I'm not going to write that the function is decreasing from -infinity to -2 and -2 to 0 because it's in my sign chart. Are you okay with that? But I am going to write that we have a min at 0, comma. Do I plug 0 into my function or to my derivative?
No, function.
Function.
Panic. Yeah, if you want to find the height, if you want to find the exact point, plug it into the original function. And we already plugged in 0 to the original function. That's 4.5. So we plugged these numbers into the derivative to find out where the function, if it were, we plugged those numbers into the function's derivative because it tells us where the function's decreasing and increasing. If I want to find the actual point, anytime I want to find an actual point, I got to plug into the original function. So if I plug 0 into my function, you get -18 over -4, which is 9 over 4, which is 4.5. Okay. Let's do the same thing with the second derivative. What color should the second derivative be?
I feel like red, no.
What?
Or black, I'm down for like black.
You know what? It's actually, I so don't use black that it's,
Highlighter.
no,
Rainbow one.
you're crazy. No. All right, do you guys find the second derivative?
Yeah.
You guys find it and then we'll check it. If you already found it, you could start trying to graph it. See if you can actually put it all together. And I'll give you guys like a minute head start and then I'll start.
Is it gonna be x squared minus 4 over 4 on the bottom? Or is it?
At some point, yes, but I think an x squared minus 4 on the top will emerge and that'll
Yeah,
divide out
but
with
like-
the ones on the bottom. And so
My main question was x squared times x squared is x to the 1.
x squared minus 4 squared. Is that what you're talking about?
I'm just saying, is x squared times x squared x to the 4?
Yes,
Sorry.
add the exponent.
Okay, that's simple. That's all I need.
And x squared squared is also x to the 4th. But x squared plus x squared is not x to the
2x
4th.
squared, right?
Sorry. that's not-
Wait, so what's x squared minus 4 to the square?
What do you mean, what is it?
Oh, I thought you said it simplifies to something else.
No, we're just talking about at the end of the problem, there's gonna, what the denominator is gonna look like. Or that's what I thought he was talking about, but I was wrong.
It's not so. Multi-row. So do you have to multiply it out to be like x, x before plus? You know, does this make sense? It makes sense in my head, but I can't really like. In order to like, g, like you have to, if you're doing the,
What's that?
if you're doing the derivative, like the second derivative, and you have like an x squared to the, and then x squared minus 4 squared, right, in the denominator,
Yep.
you have to bring that up to the,
Yeah, when you do low, that's the low,
yeah, so.
d high minus the high times the derivative of the bottom.
Yeah, so for the derivative of the bottom.
That's the
right?
chain rule one, yeah.
Okay. That's okay. It's okay.
It could be one of those things that you just always hate, or it could be that thing that you're just gonna get good at. Make it be that thing you get good at.
I'm just stuck looking at Ralph whenever I look at you.
What's that?
I'm stuck looking at Ralph whenever I look at you.
Ah,
He's everywhere.
all right, I'm gonna start, and you guys can see if you get something that I got.
Yeah, let's do that.
You good? You think you got a final answer? Did you distribute the numerator? Did you distribute the numerator, or did you factor anything out? There's a constant in there, but it doesn't matter if you leave it all in. Okay, it doesn't matter. All right, so low d high minus high d low over low. So this is the part that I think that kind of like makes people have to
Yes,
slow down on.
that's correct.
When you do, if you do like 15 in a row, not even, maybe like 6 in a row, you'll get quicker at them. But if you only do one every once in a while, then you never let it sink in.
Is there like a quick?
Is it? I just said it. Yeah, do a bunch of them until it's easy.
Let's really take 20 out.
I'm actually gonna leave the 20 in, but
I'm just gonna go to the chain rule.
no. There's nothing wrong with leaving the 20. You can absolutely take the 20 out. And if you look at my answer key, I think I did take the 20 out. I'm gonna leave it in this.
And an x squared minus 4.
So yeah, so I'm definitely taking the x squared minus 4 out. And you absolutely can take the 20 out. I know I've done that in previous examples. The only reason why I'm not is because I'm just gonna end up distributing the 20 in there anyways. It's just a constant, and you can always, when you're finding where the second derivative is 0, it's just a constant. It doesn't. Tomato. I don't know. Do you guys want me to take the 20 out? Does anyone care? All right. So if I take one x squared minus 4 out, there's still one factor of x squared minus 4 left. And there's still that 20 that I didn't take out. Sorry. Minus, let's see, that x squared minus 4 is gone, but everything is still here. So what's 20x times 2? That's 40x. And what's 40x times 2x? Is that 80x squared? No, there's an x squared minus 4 here that's going to divide out with one of these. So there's going to be three factors of it left over in the denominator. Great choice on the black ink. And then I'm just going to clean up the top. That's going to be 20x squared minus 80 minus 80x squared over x squared minus 4 cubed. What's that?
I just looked at the chain rule and it makes sense. So we're good.
Excellent. And then we get 20 minus 80 is negative 60. x squared minus 80 over x squared minus 4 cubed. Talk to me, Gabby. Did you have a 20, like, did you have 20 in parentheses times?
20 out, yeah.
Right, and that's what I have here. So here I had 20 times negative 3x squared minus 4.
Yeah.
Or negative 20, and then in the parentheses, positive 3x squared plus 4. It's not going to matter. What was the purpose of finding the second derivative? So we could find out where it's 0 does not exist, so we could find out the points of concavity. So we want to find out where this thing is 0.
So the second derivative is where you find out points of concavity?
Yes.
Cool.
Or a DNA. It's not going to exist in the same exact place that everything else didn't exist, plus or minus 2, which makes sense because that plus or minus 2 is our asymptotes. So these are not going to be points of inflection, though.
So you just ask.
So there's no point in it?
Correct.
So that means it's just.
Oh, wait, there might be one at 0. We don't know
I
yet.
don't think,
I don't think so either because we have a min there.
yeah.
So it's not a point of inflection, it's an asymptote. So the second derivative is 0 at 0. So let's go up here and make a sign chart right next to it. I like doing them next to each other. So we got to look at 0 and plus or minus 2 again. And then we got to plug some numbers into our second derivative. By the way, did anyone get the second derivative? I heard you got it. Yeah?
It makes sense now.
Got it. I didn't get it, but now that you see how to do it, you're good.
Correct.
Right. Yeah. So what's dangerous about that is like you still need to go do one on your own until you get it right.
Yeah.
Like I can see you score on a PK and be like, oh, now I know how to do it, but like I gotta go do it. So that I can do it.
Sensitive subject.
All right, we'll talk about it.
Yeah.
Okay, so we need to plug numbers in our intervals. I'm just going to use -3 again. I'm going to use -1 again. I'm going to use +1, and I'm going to use 3. So where is it? So the denominator, the denominator could be negative. Okay, so I'm just going to tell you what it is. Do you guys, I mean, we can plug numbers in together, but if you say that you don't feel like doing that, and I can just tell you if it's positive or negative, I'll do that.
But I have a question.
Yes.
How did you get 0 on?
Did I skip that? Sorry, I didn't do this part. That's my fault. I jumped the gun there. When does 60x squared minus 80 equal 0? Right. So that's when 60x squared equals -80. So that's when x squared equals -8 over 6. So x squared can never be a negative number, right? No solution. Unless we're dealing with complex numbers. So I added the 60x squared to both sides, but then I switched the right and left side. So I put the -80 there and the positive 60 there. That's what I did.
Okay, just.
So
Took the 20 out.
I do that.
you wouldn't,
I
yeah,
add the plus
the 20
eight.
wouldn't have changed anything. What's up?
Nothing, I'm just saying a different way to do that. It's way longer, but it makes sense there.
It's one of those things where, like, you know, there's
I would
100.
just multiply each side by -1.
Boom.
That's what I would do.
Okay. All right. So we just need to look at 2 and -2. So in that case, we just need to look at these numbers. So I got a negative, positive, and a negative. No points of inflection, but I know the concavity now, and now we can start graphing. All right.
I think you forgot to put the second derivative next to the 0.
What do you mean?
Like F and then like the 2, like the quotation mark thing. You see where you put the positive?
Right here. Yes.
No. When you plugged in 0.
Yes.
Yeah, it says like the first derivative. I
Oh,
think-
there's two things on it, right?
Yeah.
Thank you. Good catch. Perfect. Okay, so let's graph this thing. Should we get the graph paper out?
Yeah, break it out.
You guys earned it. Guys, it's 1:30 and this is only one example. OMG. Okay, so we know that the x-intercept is at 3 and -3. So 1, 2, so -3 and 1, 2, +3. We know we have an x-intercept at 0, 4.5. 1, 2, 3, 4.5. That is also going to be a min. So I'm just going to leave that there for myself for later. It's going to be a min. The fun stuff, the asymptotes. We have one at 2 and -2, right? Now I'm wasting everybody's time. Let's do orange. And then we have a horizontal asymptote at 2, right? Do you want to do this one a different color or keep it orange?
This one's gonna be teal.
No, orange
Ooh, I
raspberries.
like teal.
Orange raspberries.
Yeah, but teal looks so nice. Alright, then we got a graph in teal.
Yeah, we'll grab it.
This was it. Which one's teal?
I don't know.
The one that's like a little bit like. not-
You gotta get a
Oh,
custom one.
The color is
Click the green plus.
Is this close enough?
Can you draw on it?
Oh, never mind, I lied to you.
I can't have two. I can't have
Oh,
two.
we picked teal.
More colors.
The galaxy. Wait, can we graph and rainbow?
Come on, let's get a little festive.
All right.
And rainbow?
Let's get a little nuts. Let's get a little crazy.
Oh God, I hate it. I hate that.
Here
No,
we go.
we're going this color. All right. So, all right. So the function is decreasing up until -2, and it is concave down up until -2. So -2 is this vertical intercept. So, excuse me, the vertical horizontal vertical asymptote at -2. So it's concave down all the way till I get here. It's decreasing until I get there. And based on these asymptotes, it's got to go something like this. It's got to go through my 0. And that fulfills the situation, right? It's concave down up until -2. Perfect. It's decreasing, definitely decreasing. So, and we go through our intercept. All right. And then from from -2 to 2, it goes from decreasing to increasing. We have these asymptotes here. I think we all know where this is going, right? It's got to go. We know we have a min there. All right, there it is, and it's concave up. It's concave up the whole way, right?
Yep.
So this thing happened. Stay positive. All right, and then what happens from 2 to infinity? It's going to stay concave down, but it's increasing. So to be concave down and increasing, it's got to look like that. So it's going to have to respect those asymptotes, respect the x-intercept, and look something like that.
Oh, my brother came in my room when we were like doing notes one day,
Yeah.
and he said that he really appreciates the way you take notes. So
It is
I was
nice.
supposed
It
to
is
tell you
nice.
that.
It is
I
really
like how you
nice.
take notes.
Oh,
I
like
don't know if
Decent
anyone that's
handwriting.
weird, but like it makes it.
He's like, see, this is really good. Like, look, the way he takes notes. There are some professors that are awful at it. So he was
I enjoy a good note take.
And also,
Teacher.
I have pretty good handwriting, so.
I enjoy
They do certain things all the time.
It's a pretty nice looking graph too.
Not bad, right?
Yeah, that's pretty
It looks
symmetrical.
like a.
Like it.
Use the ruler, you know,
You guys.
beautiful.
Like a creepy
It's just
bird.
color coordinated
Looks
with
like a
the-
creepy
You know what
bird.
helps is the OneNote allows for this.
Like the owl.
OneNote
and
knew.
Atlas.
Yeah.
Yeah.
I did become a teacher just so I could write on whiteboards.
The wings, like wing, like that wing.
You come to class with like a bunch of these, and you're like, it's gonna be a good day, guys.
You know,
I just.
Except the yellow one. It's gonna be an extra good day.
Mr. Florida, you're really good at like
This
making
dude.
images out of your graphs.
I guess it's just compliment.
Make Ralph into a girl.
All right, so I know what you're all thinking. Let's just graph it and see what actually happens. So y equals 2x to the second power minus 18. That's the numerator divided by the denominator, which is x squared minus
It doesn't look right.
4, close parentheses. All right. So,
It's a big moment.
you know, we did a lot there. A lot of places to make a mistake.
30 minutes.
I hope it looks like what that looks like. Graph in 2D. Now, wait. There's more. I showed you this last time. Key graph features. Ready? Did we have -3 and 3 as our zeros? Yeah, we did. Did we have a y-intercept of 4.5, which is really 9/2? Yep. All right. Was that also our minimum?
Yeah.
I think so. Did we have a max? We did not. We could plug any number in except -2 and 2 because that's where our asymptotes were. And inflection points? Nope. We talked about that. The increasing, decreasing stuff? The monoticity? Yeah, that matches what we said.
I know a lot of this is.
Vertical asymptotes, 2 and -2. Horizontal asymptote at y equals 2 as x goes to plus or minus infinity. Look at us. And how great is that? We could have just not done any of this and had that tell us everything, huh? That wouldn't have been as fun. We're not psychos. Okay, so that's it. People at home, I'm gonna put you guys in breakout rooms, and I want you guys to do start the homework.
I say you give us like 12 of these.
Hey, Gary.
So the homework, guys. Oh my gosh, there's only 3.
Yes.
And among the 3, only one of them is a quotient rule.
Yeah, it's not like one of these took us half an hour.
It's not like this will take us 3 hours.
All right, you know what? Take tomorrow off and just spend all day tomorrow doing it. That's fine. All right, you guys, on me. All right,
2 days at least. He's organized and generous.
all right.
All right, let's calm it down.
People at home, I'm gonna put you guys in breakout rooms. If you have any questions, let me know.